What's going on, guys? In this video we are going to see how to find out the operation mode of this BJT. To find out this one, we have to know whether this VC is greater than VB. If the VC is greater than VB, then this is in active mode. If it's not, this is in saturation mode. Okay, now to find out the VC, there's a formula. VC is equal to VCC minus IC times RC. Now VCC is 10 voltage, that's here, and minus IC we had to find out. RC is already there. RC is 1K, that's provided right here, so that's not a problem. We had to find out IC times 1K. Now to find this one out, what we are going to do is we are going to assume this is in active mode. If we assume this is in active mode, what's going to happen is the voltage drop right here should be 0.7. if we assume this is in active mode, 0.7 voltage. Now from this one we can apply KVL for this one and find out whatever we can find. Now let's go ahead and create the equation. So this is IB, since this is base, emitter, collector. This is collector, base, emitter. So base is IB, and this one is IE because this is emitter. Okay, this is IC because this is collector. Now here we are going to apply KVL. If we apply KVL, since the current is flowing from negative to positive, this is going to be negative 5 voltage plus IB times 100K, IB times 100K, and then we have a voltage 0.7 voltage, 0.7 voltage, and after that we have a resistor right here, and IE is going through that, so IE times 1K. The all together it should be equal to 0. Now here you can see we have two unknown variables. We have this IB and IE as well. Okay, now to make this one unknown variable, we have to use this equation. This is some generic equations we have, that is IE is equal to IB plus IC, and also there's another equation for I collector, that is beta times IB. So from this one, since to make everything in one variable, we already know beta is provided in the question, that's here. So to make everything in one unknown variable, what we can do is we can substitute this IC thing for this one. If we do that, we only have IB unknown, so in that way we can have only one unknown variable because we already have IB right here. Instead of this IE, we substitute everything in terms of IB. We can solve for IB easily. Okay, so let's write the new formula for IE then. IB plus beta times IB, beta times IB, and we already know beta is equal to 100, so we can plug it right here. 100, let's write this one, IB plus 100 IB, so 101 IB. Instead of this IE, we can just plug 101 IB. Okay, now let's go ahead and plug it right here. 101, and this is going to be, since multiplied by K, this is going to be 101 IBK, or we can say 101 KIB. So 100 KIB plus 101 KIB, and here we have negative 5 plus 0.7, that is negative 4.3. If I move it to the other side, that's going to be positive 4.3. This is going to become 201 KIB is equal to 4.3. Therefore, IB is going to be equivalent to 4.3 divided by 201 K. And the answer is going to be in milliampere, because if you divide by K, that's going to be milliampere. And if you simplify this one, this is going to be 0.021 milliampere, and that's equivalent to 21 microampere. Okay, now this is our IB. IE is equal to IB plus IC, and we have IB. Now from this one we can calculate IC. IC is equal to 100 times beta times IB. Beta is 100. 100 times IB is 21 microampere, and that's going to give us 2.1 milliampere. 2.1 milliampere. Now we have IB, actually IC, this one is IC. IC is equal to beta times IB. IC is equal to beta times IB. Now this is our IB and this is our IC. Sorry about that. Now let's go ahead and continue. IC is 2.1 milliampere. Now if we know IC, then we can solve for VC, because we only didn't know IC before. Now we found out IC, so we can solve for this VC, because we had to compare VC and VB to find out whether this is in active mode. If this is satisfied, this is active. Okay, let's see if this is satisfied, but we don't know yet. Now 10 minus 2.1 milli times 1k. Milli and k cancels each other, so we will get 10 minus 2.1, that's going to be 7.9 voltage. This is our VC. Now we have to find out what is VB is, because we have to compare VC and VB. Now to find out VB, first what we can do is, we have IC, IB, right? So we can find out IE. If we find out IE, that's going to help us to find out VE. Here voltage emitter, that's VE. Now let's find out IE first. IE is equal to IB plus IC. IB is 21 microampere plus 2.1 milliampere, and that's going to give us 2.102 milliampere, because 21 microampere mean micro is 10 to the power minus 6, milli is 10 to the power minus 3. So when you add, this 2 will go 3 times from this one. That's why 2.102 milliampere. Now we have IE, so we can calculate VE. VE is basically that resistance here, and IE. VE is IE times resistance, 2.102 milli times 1k. Milli and kilo cancels each other, so we will get 2.102, approximately we can say 2.1 voltage. Now we have VE. Now how to find out VB? Now we know that this VBE has to be 0.7. That's what it is. Now if we know VE, then we can calculate VB by calculating what voltage. If we subtract, VB is nothing but VB minus VE, and that's equivalent to 0.7. Now we know that VE is equal to 2.1. If I subtract like from that value, that's going to give us 0.7. It should be 2.8 to give us 0.7, right? So from this one we know that VB is 2.8. So VB is 2.8 voltage. Now what we have to do is, we have to compare VC and VB and see whether it is satisfying this one. If VC is greater than VB, it's active. So from this one we know that VC is 7.9 voltage. VC is 7.9 voltage, and VB is 2.8 voltage. Is it? Yeah, 2.8 voltage. And from this one we know that VC is greater than VB, right? VC is greater than VB, so it's satisfying this condition. If it satisfies this condition, it means this BJT is in active mode. This is in active mode, and that's how we do that. I hope you guys find this video helpful. Thanks for watching. And if you are trying to learn electronics or circuit analysis, there are a bunch of videos in my playlist. I hope you guys watch that too, and don't forget to subscribe. See you next time.